Always encrypted is a security feature in Azure SQL database, Azure SQL Managed Instance, and SQL Server that protects sensitive data such as credit card numbers, social security numbers, and other personal identifiers. Unlike transparent data encryption, which secures data at rest, always encrypted protects data both at rest and in transit by ensuring encryption happens at the client side before data reaches the database. This means database administrators, cloud operators, and other high privilege users cannot access the plain text data. This ensures separation between those who manage data and those who can view it. With this protection, you can confidently store highly sensitive information in the cloud while reducing the risk of insider threats or malicious activities. How always encrypted works? Always encrypted ensures that encryption and decryption occur only within client applications, never in the database engine itself. This is made possible through an always encrypted enable client driver, which automatically encrypts data before sending it to the database and decrypts encrypted query results before displaying them to authorized users. This way, even if an attacker gains access to the database, they will only see encrypted ciphertext, not the actual data. Always encrypted relies on two types of cryptographic keys, such as column encryption key, which is CEK, and column master key, which is CMK. Column encryption key encrypts the actual data in the database columns. Column master key protects the column encryption key, and it is stored outside the database in trusted key stores such as Key Vault, Windows Certificate Store, or Hardware Security Module. The database engine never stores or uses these keys in plain text. Always encrypted supports two types of encryption depending on how you need to query and secure your data. First one is deterministic encryption. Deterministic encryption encrypts the same plain text value in the same ciphertext every time. It allows point lookups, equality joins, grouping, and indexing on encrypted columns. It is best for government ID numbers, email addresses, or any data used in search queries. Since the same value always results in the same ciphertext, attackers may infer patterns and guess sensitive data. And second one is randomized encryption. Randomized encryption encrypts the same plain text value into different ciphertext each time. It is more secure but does not allow searching, grouping, or indexing on encrypted data. It is best for highly sensitive data such as personal notes, investigation comments, or confidential reports. Bottom line, which one to choose? You should use deterministic encryption when you need to search or group data, and you should use randomized encryption for maximum security when queries aren't required. Let's unpack how queries work on encrypted columns. For encrypted data to be read or modified, two conditions must be met. First one is the user or application must have access to the column master key. And the second one is the database connection must have always encrypted enable. If either of these conditions is not met, the user will only see encrypted data, which is ciphertext instead of plain text. Query processing workflow steps are listed on the screen. Let's discuss them. In this case, the application sends a query to the database. The SQL driver detects which parameters need encryption and retrieves metadata, such as encryption algorithm or keys. The driver encrypts the parameter values before sending them to SQL. The database processes the query using encrypted values. The result set is sent back with encrypted data, and the SQL driver decrypts the value before returning them to the application. Since SQL Server never sees the plain text data, no sensitive data is ever exposed to the database engine or administrators. Despite of greatness of always encrypted feature, it has few limitations as well. Let's unpack those limitations. It only supports equality comparison, but no range queries. Sorting and indexing are only possible with deterministic encryption. Joins and filtering are restricted unless deterministic encryption is used. Certain data types are not supported, such as XML, timestamp, text, something like that. There is a complete list of unsupported data type. Computed columns, default constraint, and full text search are not supported. And modifying encrypted column definitions requires re-encryption outside the database. Let's discuss some of the best practices for always encrypted. You should use deterministic encryption for searchable data, such as IDs, email addresses. You should use randomized encryption for high security data that does not need querying. You should store column master keys in Azure Key Vault to ensure strong protection. You should avoid unnecessary decryption operation to reduce performance impact. You should use parameterized queries instead of hard-coded literals to prevent errors. And you should monitor key usage and rotate keys regularly for better security compliance. When to use always encrypted? You should use always encrypted when you store sensitive data, such as credit card details, SSN, or medical records. You should use always encrypted when you need to protect data from privileged users, such as DBAs or cloud operators. You should use always encrypted when you want to keep encryption keys outside the database for maximum security. You should use always encrypted when you need a strong security but still require equality comparisons in queries. You should use always encrypted when you want to comply with regulatory standards such as GDPR, HIPAA, or PCI DSS. You should avoid always encrypted if you need sorting, range queries, or complex calculation on encrypted data. You should avoid always encrypted if you need to use unsupported data types like XML, text, or computed columns. And you should avoid always encrypted if you need to perform extensive joins or filtering without revealing key information. Bottom line, always encrypted ensure the highest level of security for sensitive data by keeping encryption keys out of the database and ensuring only authorized applications can decrypt the data. While it comes with some query limitations, it reduces insider threats and strengthens compliance. If your organization handles highly confidential data, implementing always encrypted in Azure SQL database or managed instance is a critical step toward data protection and regulatory compliance.